Hey, my, yo. Today, what are we doing today? We're working with the normal distribution. Thanks to PLTW for making some of this PowerPoint right here. If you guys don't know about PLTW, they're amazing. They make awesome curriculums. I love teaching this class. It's great. Check it out. Really good. Anyways, thank you to them for the PowerPoint. I added a little bit onto it. We're talking today about the normal distribution and what that is. So here is what Bing has to say. Don't know why I'm using Bing these days. In probability theory, the normal or Gaussian distribution is a very common continuous probability distribution. Normal distributions are important in statistics and are often used in the natural and social sciences to represent a real valued random variables whose distributions are not known. So anyways, what does all of that mean? What is it? So basically a normal distribution is where most of your data is kind of centered around the mean, right? Kind of right in the middle there. And then the further off you get to the edges, the fewer data points there are, right? So something like height is normally distributed, right? Most men are like right there around 5'8", 5'9", 5'10", 5'11", 6 feet tall, right? But then it's very rare to find those 7 feet tall people. It's very rare to find those really short people, yeah? So that's kind of an example of a normal distribution. You got a lot right around the mean right here. Let's look at another one. You got a lot right around the mean there, and you have very few kind of tapering off to the edges. So anyways, here's a dot plot. I modified the spreadsheet a little, right? You got 6 zeros. There's 6 zeros. How am I doing on batteries now? I just got 33 minutes. We should be able to make it through the video. We got 6 zeros. We got 5 ones, right? So I just did my basic dot plot right there. Then I just turned that dot plot into a bar graph right here, or Project Leadway did. Again, thank you. We got that. And then also I kind of fit this under a bell-shaped curve. So a normal distribution always has that bell curve shape. Right? This is a critical idea here. Let's grab a quick image of it. Nice. So you can see these bell curves might look a little bit different depending upon the data and depending upon, I don't even know. They might look a little bit different, but they always have that kind of bell shape, right? Where you got most of the stuff in the middle and then you got a tapering on the edges. The most classic normal distribution follows this one right here, right? You have, and it's also based upon the standard deviation. So you got the mean right in the middle, right? And you got most of the data near the mean. That's why the graph is higher. Now the key intervals involve the standard deviations. So you have the mean right in the middle. You have the mean plus 1 times the standard deviation. You have the mean plus 2 times the standard deviation. Mean plus 3 times. Mean minus 1, mean minus 2, mean minus 3. 68% is within 1 standard deviation of the mean. 95% is within 2 standard deviations of the mean. And 99.7%, almost 100%, is within 3 standard deviations of the mean. Okay, so let's go ahead and see what we mean by getting, here, and then here is just that information written out, should help you put it in your notebook. Okay, so let's go ahead and see what we mean with this. I downloaded this data off of Google. It was promised to me to be normally distributed. We'll find out if it actually is or not. So now I already sorted this, but it's definitely something you want to do. Okay, I gotta put the microphone down. Sorry if it gets quieter. I need to have some hands on the keyboard here. I'll try to bend over, talk. I know there's been an issue with it not being loud enough. Okay, so I'm gonna highlight my data. I'm gonna go to data, sort range by column A to Z, right there. Boom. Now my data is sorted from low to high. You could sort it from high to low too if you want. It's all good. Okay, now I'm gonna highlight everything. I'm gonna use a keyboard shortcut. I'm gonna use Control Shift down, and it's gonna highlight that whole section right there. Boom, awesome. Insert chart. Nice, okay, we're gonna grab our histogram. Yes, and where are we? Oh, we probably need to scroll up. So I'm gonna hit Control up, yes. Okay, now at the top of our page, here is our histogram. Now, why can't I grab it? What's going on with my computer? Okay, yes, there's our histogram. You can see that bell curve shape, right? I'm gonna make a wild guess that the mean is at 46, right? And you can see right here the tapering off of the edges, right? Now note that this isn't quite the histogram we want because we don't yet know our standard deviation. We're going to figure it out though. We're going to check this out. Okay, so what I'm going to do right here, I'm going to come over here and I am going to calculate my mean and I'm going to calculate my standard deviation. Awesome. So I'm going to click right here. I'm going to type in equals average, and I'm going to take the average of all the data right here. Okay. And what is my average? Sorry, I'm zooming around the spreadsheet a little bit. So my average is, oh no. My average is 45.5. Okay, so it wasn't actually 46, it was 45.5. And my standard deviation is equals STDEV right there. STDEV, grab that standard deviation right here. Highlight everything. I'll do it manually this time. Why not? Takes a lot longer than using that Control Shift keyboard shortcut. You know what? I can't even handle it. I'm going down. All right. That is the one. Okay, let's Control Z up. We'll find it. Yep. Okay, so there is our standard deviation. Now we want to compute our standard deviation to within one extra decimal point than what our mean is. So, or than what our data is, pardon me. So our mean is right here, 45.5. We're going to also do our standard deviation to that same number. There you go. Or can we do one more? You know what? Let's go one more just to have fun. Okay. Or not to have fun because it's the right thing to do. Yeah. Okay. Let's center this so it looks a little bit better. Yeah. Mean and standard deviation. We'll widen this column up a little bit. Yeah, we like that. Okay. Good. Okay. Now let's change up our histogram a little bit. Let's look at it right here. Let's do the advanced edit. Let's change that bucket size right here. Bucket size. Let's go with what was it? 4.92. I think it was 3.92. 3.92. There we go. And let's update it. Now the unfortunate thing is it's not centered at the mean anymore, which is disappointing. I hear ya. But you can see it's we still have that normal distribution, right? And now if you have the Excel and you got the tool pack and you got all that stuff, you can make that perfect histogram. You know, we're just going to go with this. I think this will work. Okay, and we're going to do one other thing that's really awesome and really lets you see, kind of lets you trick your way into making the actual normal distribution. You'll see what I mean right here. Okay, so here we go. We're going to type out mean, and then we're going to do mean plus 1. We're going to do mean plus 2, and we're going to do mean plus 3. There we go. Mean minus 1. Uh-oh, low battery. Mean, come on, baby, you could do it. Minus 2 and mean minus 3. Lano, you want to get me my charger out of my backpack? Would you be willing to do that for me? Sorry. Oh, yes. Okay, forgive me. It's tough life over here. All right, so there's our categories. Let's go ahead and center them so they continue to look good. Right there. Okay, okay, so now we know what our mean is. Let's just go ahead and copy that and paste that. We like this, but no, we don't like this because the reason this number is different is because if you look at it, it changed from being A5 to A104, whereas this one was A2 to A101. So one of the great things about Google Sheets is it moves your data range for you, right? So I moved this down, 3 blocks? So it moved my data down 3 blocks from 2 to 5, from 101 to 104, right? We moved down 3 blocks, moved the data range down 3 blocks. Now the way to get around this is probably just to type in 45.5. Perfect. Okay, now I'm going to do 45.5. Oh, now I'm going to type in my equals. I'm going to type in 45.5 plus 3.92. 92. Cool. Because I forgot my equal sign. That was silly. Okay, there's my equal sign. Now it's going to know, okay, I want to calculate something. We got that. All right, now we're going to do this. We're going to do it a little bit easier way. We're going to go equals, and we're going to click on the mean square. Then we're going to say plus. I'm going to do 2 times, and I'm going to click on the standard deviation. No, and I'm going to type in, again, 3.92. There we go. Now we'll do it one more time, and we'll see what happens. Equals, click on this one, plus 3 times the standard deviation, 3.902. Actually, wow. And you know what? Yes, okay. I just thought of a much easier way. So let's use a trick for the other side, for the subtraction side. Let's do equals mean minus 3.92, and then let's just copy it. Now we're going to take advantage of the fact that it moves our reference, right? So I'm going to do a Control C, I'm going to do a Control V, and a Control C, and a Control V, and there you go. It did it for us, because look at this, right? G26 minus 3.92. Now I'm just going to subtract 3.92 from this cell, and from this cell, right? So as I go left, it just counts down. As I go right, it counts up. Very cool. Okay, so now these are where our columns lie. Let's see. So mean is 45.5. We got mean plus 1, mean plus 2, mean plus 3. So you can see right there. Now I'm going to use mean plus 1 to represent this area right in here, this bar. This is going to be mean plus 1. So it might not always be mean plus 1. It might be mean plus, 0.01, right? Might be mean plus 1 standard deviation. It might be mean plus a half a standard deviation. But anything in here is going to be counted by mean plus 1, and so on. So here's what I'm going to do. 45.5. There we go. So right at this breaking point between 45 and 6, I'm going to do mean minus 1 and mean plus 1. And let's put it, yeah, okay. That happened. Okay. Now we'll go back up here, and 49.42, okay. And what's our other number? 53.34. So let's see, 49 and 50 and 53 and 54. Okay, so 49. No. Why is my memory okay, 49 and 53. All right, so 49. So this is mean plus 1, mean plus 1. No. And mean plus 2. There you go. And then 53 to 54, mean plus 2, mean plus 3. One thing I'll mention is that you want to be really, really careful not to put any extra spaces after your, after your typing here. I was getting extremely frustrated because it didn't work, and the problem, which my lovely girlfriend pointed out, was that I had an extra space at the end. So anyways, 43 to 44. Yes, so there is nothing lower than 43. Yes, so 37 to 38. Here we go. This is mean minus 3, and this one is mean minus 2. And then we have 41 and 42. So right here, mean minus 2 and mean minus 1. Okay, so now I've labeled all of my breakpoints, right? So I'm splitting it up into the bins manually, right? I'm picking which bin does it go in. Mean minus 1, mean minus 2 right in there, mean minus 3 in there, mean plus 1 right in there, mean plus 2 right in there, mean plus 3 right in there. Hopefully the sound's synced up, so that's not really confusing. And then I'm just going to use a copy and a paste, copy and a paste, a copy and come on. All right, time to use my shift control trick and a paste. Time to use my control down trick, control C, control shift down, control C. Oh no. Okay, all good. Control C, control shift down, up, control V, control down, control C, control shift down, control shift V. Yes, so I'm filling it in, control down, control C, control down, control V. Okay, so got it filled in. All right, so I've split it up now manually into bins. Now, let's find out for sure if this thing is exactly normally distributed. We'll see. Okay, insert chart. Now, you can do a pie chart. That's looking promising, though a little weird. Whatever, we'll deal with that. Okay, let's do this chart type right here. Now, okay, yep. So this, yeah, I thought this could happen. All right, so let's insert it. Now you can see your favorite professor here, your favorite teacher here, might have made a little mistake and might have put a little space in between the plus and the 1 right there, right? You see that? So we got 1 plus 1, and we got all the rest are plus 1 with no space. So let's go see if we can find that guy. And yeah, there it is right there. Okay, let's see if our chart automatically updated. Let's hit enter. Let's see. Okay, oh, there we go. That looks so good. Very, very nice. Yes. Okay. So it looks normally distributed right there, doesn't it? All right, we could do our advanced edit, put all our labels in there. Let's do this. Let's do advanced edit, and let's go ahead and put our labels on there. Data labels, where are you? Yes, our values. Update that. Yep, it didn't work. Okay, well, what are you gonna do? Labels, series, column 1. I don't know how to do it. You guys figure it out. You know, what are you gonna do? All right, let's put one more thing in there. Yeah. Insert chart. Let's put the pie chart in there. Insert the pie chart. So there you can really see those percentages now, right? You got 34%. We got 34.13%. We got 14%. We got 13.59%. Can't really see this one. Be willing to bet it's probably 2%. So there you go. I think we can pretty much, this would be pretty easy to say it's normally distributed, right? We got our histogram this way. We got our histogram this way. We got our histogram, or we got a pie chart with our matching percentages. So now let's go here and let's talk about what your assignment is. Okay, so you want to analyze your catapult and slingshot data. You're going to write one paragraph. Okay, I kind of learned, you know what, I think the intro, the conclusion, it was just a little awkward. It was, I don't know, maybe it just felt forced to me. Thank you guys for teaching me that. You guys were like, you know, I think some people kind of said, is this really like worth doing? I don't know, maybe it was, maybe it wasn't. Anyways, for this one, we're just going to write one paragraph. You're answering the essential question, is your data normally distributed? Yes or no? So for level 4, you're going to provide evidence based on the graph, the other graph, and the percentages. Okay? So there you go. If you want a level 4, you do all of that. You talk about all that. You calculate all that in your paper, and then, you know, write your paragraph including all those. For level 2, you're just going to choose one or the other, right? You're going to do this graph, or you're going to do this graph, or you're probably going to do this graph because that one's the easiest to do, right? All you got to do is calculate the standard deviation and change your bucket size to be that. You just go to advanced edit, and you go right here, and you bucket size it to whatever your standard deviation is. Then you can probably at least have some idea whether there's that bell curve shape. Anyways, that's what you got to do for your catapult slingshot data. The more data, I'll tell you right here, right now, the more data you have, the better. Okay? The more data you have, 10 is the bare minimum. If you can get 20 or even 30, you know, it takes, 10 seconds to launch the cotton ball and record it? Not very much, right? So do that as many times as possible. Get yourself as many data points as possible. Then go ahead and type them in and see what you got. All right. So I'm ending the video. Hopefully it's not too long. Probably is. Thanks. See you next time.